we've been in measurement for a little while now. We've been measuring all kinds of things. We've been measuring perimeters, we've been measuring areas, all kinds of different shapes that we've been measuring, right? What was the most recent one? Most recent kind of shape? Round thing? Circles, very good. And we learned that the perimeter around a circle had a special name. What was it called?
Circumference.
Circumference, very good. And its area and its circumference, they have to do with a special number. Does anyone remember what the special number is?
Radius.
Pi. Pi is this weird number, right? 3.1415, blah, 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 blah. Strange thing. So, where we're going to move from there is now about thinking about more dimensions. Now, more dimensions, like before we get to that, we better think about what dimensions are. So what is a dimension? A dimension is a direction that you can do one of two things in. It's a direction you can move in, or a direction you can measure in, right? A direction you can move or measure in. So for instance, I could say, you know, I can move left and right along here, right? This is your left, right? And this is your right, okay? So I move back and forth and back and forth. So in some ways, I've got one dimension that I can move along here, okay? One dimension is from that side to this side. And we've seen one-dimensional things before. For instance, the number line, right? It's got 0 in the middle, okay? And you remember when we were covering integers, okay? Going to the right, you've got like 1, 2, 3, 4, 5, etc. And then going to the left, you've got all the negative numbers, okay? And left and right, positive, negative, that's the only directions you can go in. Yeah?
Isn't that 2 dimensions? Because like the lines.
Okay, yeah, so in this case, what I mean by a direction is,
just a
like,
line.
it's the line I can move along. You can go back and forth, but you're still going in the same, along the same dimension, along the same direction, okay? So in that case, back and forth are different ways of moving along the same line, okay? Right, so that's what a dimension is, okay? So therefore, when we move to these things, they're all about measuring in different kinds of dimensions, right? If a dimension is a direction you can move or measure in, okay? Then a length is how much space an object takes up in I'm just going to write it like that and not make any comment, okay? A length is how much space an object takes up in one particular dimension, okay? So for instance, when we had a look at some of the shapes that we measured in the last few lessons, okay? For instance, I can say, all right, here's a rectangle. Here's a rectangle, okay? When I say, all right, what's its length? What's its length? Its length is how much space does this thing take up along this direction? Okay? That's what I mean by its length. Or I could have made this the length. It doesn't matter. I could just turn around the rectangle. Okay? So it's how much space it takes up going along one particular line. Okay? Now the reason why this is a great definition, even though it seems a bit like overly technical, is because from this definition, we can make perfect sense of area and volume, right? If this is what length is, then area is the same thing, how much space an object takes up, but it's how much it takes up in 2 dimensions instead of 1, right? It's the same thing in 2 dimensions. Okay? So for instance, when we're talking about units, right? If I said, oh, okay, there's this length across here, rather than estimate, I'm just going to actually measure it, right? So the length of this rectangle is approximately 25 centimeters, okay? 26, right? So I might say that is my unit of length, okay? But now, if I go to area and I'm going in 2 dimensions, I've got length and I've got width, I need a different kind of unit. If length is a measurement in 1 dimension, right? Therefore, when we go into area, okay, I'm going to have centimeters going this way, and then I'm going to have centimeters going this way as well, right? So for instance, if I said before, okay, 26 centimeters. and let's just say, for instance, that this is 10. Okay. We know to multiply those. We know that area is just, length times width or whatever it is. We'd multiply the numbers, 26 times 10, 26 times 10, which of course is just 260, right? But we should also multiply the units. We're going to get centimeters, e.g. 260 centimeters squared, right? Like I could write centimeters times centimeters, but we have learned index notation, which makes this a bit quicker and succinct. Yeah. So now, it's just a natural progression into this world that we inhabit, right? That a volume is, again, the same thing. How much space an object takes up, it's the same thing. Yeah, in 3 dimensions, rather than in 2 or in 1, right? So you know how I said, oh, this dimension here, I've got like back and forth over here, left and right. When we add in area, it's not just left and right, it's up and down, okay? When we do volume, there needs to be another direction to go in, right? So it's like if this rectangle could come off the board, right? Like into our 3D space, like that. Okay, yes?
Do we have a demonstration of the 2D?
No, you can.
Here we go. Okay, I can go up and down, right? So, and of course I can come closer and further, right? Now, therefore, if you got like 26 centimeters, and 260 centimeters squared, because I'm in 2 dimensions, when you have volume, you would expect, for instance, suppose this now came out another, I don't know, let's just say I didn't go very far, just 2 centimeters out from the board, okay? I'd multiply by the number 2, which would give me, what's double 260? 520, very good. But I would also multiply the units too, right? I'd multiply by centimeters one more time, which would make it centimeters cubed. Very good. So just like we say centimeters, we call these square centimeters. We would call these cubic centimeters, right? Cubic centimeters. And in fact, on your book right now, I'd like you to get your ruler out. Get your ruler out. I'm going to do mine too, but it's going to be very, very small. Okay. I'd like you to draw a cubic centimeter for me. Draw a cubic centimeter. So it should be 1 centimeter by 1 centimeter. That's the square on the front, right? And then to make a cube out of it, you'd have to go 1 centimeter into the page, right? Which of course we can't actually do, but we can represent it using lines which try and mimic what's going on. So this is what we've got, just to zoom in.